This is a deep dive podcast covering articles published on Ecogate's blog, brought to you by Ecogate, the leader in on-demand dust collection.
Dust collection runs all day, burning wash, low cash away. Dust collection, close the gate, pause the air, flow low when the costs don't rain. Turn your air the cash flow, saving now, save it the least thousand. Ecogate, you watch the savings grow.
Ever heard the saying, the biggest gains come from low-hanging fruit? Well,
Yeah.
get ready to climb for some seriously overlooked savings, because today's deep dive is all about industrial energy efficiency.
Right.
We're talking about how optimizing factories and industrial processes can be significantly cheaper and more effective
Right.
than just focusing on renewable energy generation.
Interesting.
Exactly.
Yeah.
And we're diving deep into a study called Industrial Energy Efficiency, a missed opportunity in the Inflation Reduction Act of 2022.
Okay.
So before we even get into the nitty-gritty,
Sure.
what's the big takeaway here? Why should this matter to anyone listening?
Well, this deep dive reveals, and it reveals kind of a critical blind spot
Okay.
in our push for clean energy.
Yeah.
We're so focused on new technologies
Mhm.
that we're missing huge opportunities to save energy and money
Right
now by making our existing industries more efficient.
Okay, so the Inflation Reduction Act,
Right.
or IRA, as it's often called.
Yeah.
That's a big deal, right?
It is.
It's supposed to be this game changer for clean energy.
Mm-hmm.
But this study claims it's missing something important.
Yeah, it is a big deal. And it has made some significant strides.
Yeah.
But you're right, it completely ignores industrial energy efficiency. And that's a problem.
Yeah.
Because industry consumes a significant portion of our energy.
Okay.
A whopping 33% of U.S. primary energy, to be exact.
33%.
33%.
Wow.
Yeah.
That's more than I would have guessed.
Yeah.
You'd think with a number that big,
Yeah.
be a prime target for some of those clean energy investments.
You would think so.
Yeah.
Especially when you consider that industrial energy efficiency is, on average,
Yeah.
3 times more cost-effective
Really?
than building new power plants.
Right, hold on. Three times more cost effective.
Yeah,
That's huge.
it is.
It's like finding a $20 bill in your old jeans.
Right.
But instead it's enough to power a small city. What makes it so much more cost effective?
Well, think about it this way. Building new solar and wind farms is expensive.
Yeah.
And then you need to factor in the cost of storage for when the sun isn't shining or the wind isn't blowing.
Right. Okay, so the upfront costs for renewables are definitely significant,
Mm-hmm.
but I feel like I hear a lot about how those costs are coming down as the technology gets better.
Right.
Is that not happening fast enough to make it worthwhile?
Well, you are right. The cost of renewables are decreasing.
Yeah.
But even with those improvements, it's still more cost-effective to use less energy in the first place. It's like the old saying goes,
Yeah.
a penny saved is a penny earned.
Right.
Or in this case, maybe a few million pennies.
Makes sense. So we're talking about energy efficiency in industries. It's more cost effective, but how does it actually work in practice?
Sure.
Can you give me an example of where these efficiencies come from?
Absolutely. Let's take a look at a common industrial process.
Okay.
Ventilation. Imagine a factory with large exhaust fans running constantly to remove dust and fumes. In many factories, these systems are running 24/7,
Wow.
even when the machines are off.
It's like leaving the lights on in an empty house.
Exactly. And that's where on-demand ventilation comes in.
Okay.
This system uses sensors and gates to only run ventilation when it's truly needed,
Okay.
when the machines are off. Or when sensors detect air quality is good, the system shuts off, saving huge amounts of energy.
Okay, that makes sense in theory, but what kind of real-world impact are we talking about here?
Yeah.
Does it actually move the needle?
The results are pretty incredible.
Okay.
Portland Community College, for example, saw an 84% energy savings on their exhaust ventilation just by switching to on-demand systems.
84%.
84%.
That's massive. What about a real industrial setting, not just a college?
It translates there too. Andersen Door Factory, a large manufacturer, saved 3.5 million kilowatt hours annually by making this switch.
Wow.
That's equivalent to $350,000 in savings each year, just from being smart about their ventilation.
Wow. That's a no-brainer. $350,000 a year could make a huge difference for a lot of companies. Are there other examples like this, or is ventilation a one-off success story?
Not at all. This type of thinking can be applied to so many different industrial processes.
Okay.
Think about industrial motors. which use a ton of energy.
Right.
Switching to high-efficiency motors and variable speed drives could significantly reduce energy consumption.
Okay.
And then there's process heat recovery,
Okay.
where you capture the waste heat from industrial processes
Right.
and use it to power other parts of the factory.
That's fascinating. So we're not just talking about turning things off and on. We're talking about getting smarter with how we use energy in the first place.
Exactly.
Yeah.
It's about optimizing the whole system, not just adding more energy to it.
Okay.
And remember, we're just scratching the surface here.
Right.
Imagine the potential for savings if we applied this same thinking to every industrial process in the country.
Wow. Yeah. And to really put things into perspective, let's talk numbers. Imagine if we were to replace the energy saved by Andersen door factory with wind power and battery storage. That would cost about $4.2 million.
Yeah, that's
It's a pretty hefty price tag.
it is.
Yeah. Okay.
But upgrading their ventilation system to be on demand, only $1.14 million.
Hold on. That's almost 4 times cheaper for the same result.
Yeah.
That's incredible.
It is, isn't it?
Yeah.
And that's just one example, just one company.
Right.
Imagine the impact of implementing these strategies nationwide.
Yeah.
Industrial ventilation alone accounts for 4.6% of U.S. electricity consumption.
Wow.
If we were to switch to on-demand systems nationwide, we could save 125,022 million kilowatt hours annually.
That's like powering several states.
It's huge.
Yeah. So what's the takeaway here?
I think the takeaway is it's time to look beyond the shiny new toys of clean energy
Right.
and focus on maximizing the efficiency of our existing systems.
Right.
Industrial energy efficiency is a sleeping giant, just waiting to be awakened.
This has been eye-opening. It really feels like we're missing a huge opportunity here. So a final thought for listeners to ponder. If industrial energy efficiency is so cost-effective, why isn't it getting more attention and investment? What are the barriers, and how can we overcome them? This is a question worth exploring further and maybe even taking action on.